Hello and welcome to day 17 of Jamb Mathematics in 30 days. To those of you who have been part of the series from the very beginning, a big thank you to you. And I would like to say keep your questions coming, keep your comments rolling in. Anything you would like to ask, anything you would like us to solve, please put it in the comment section and we'll definitely attend to all your comments. And if you're coming across this video for the very first time, Jamb Mathematics in 30 Days is a series brought to you by Oya Learn, where when you dedicate 30 minutes to 45 minutes of your time daily, you can get all that you need to prepare well to ace Jamb Mathematics. So if you're writing Jamb and one of the subjects you're writing is mathematics, this video will go a long way to help you get all that you need to ace that exams. This is day 17, which means you have to check it out from day 1 up until this moment. So do catch up and then we then progress till the end of day 30. So day 17 here is about the applications of differentiation. And Jamb syllabus expects that all candidates should be able to do the following that is itemized there in the objectives. They expect that you should be able to solve problems involving applications of rate of change. And when we're saying rate of change, in previous video, we looked at the case of differentiation where you have dy dx. This is what we mean by change of rate. So when you change something in respect to another term is when we talk about change of rate. So applying this where you have small increments in different functions is what we are talking about when we say change of rate. And then secondly, they expect that you should be able to solve problems involving maxima and minima values. So we'll be solving some questions from the Jamb past questions that has to do with the applications of differentiations. So please take out your notes and let's get prepared as we solve these questions. Now, this is a question from Jamb 2004, which was also repeated in 2021. And the question says to find the derivative of the function y equals 2x squared into 2x minus 1 at the point where x equals -1. That is, we're going to find the derivative of this function and then apply when x is -1. This is where we solve problem that relates to change of rate in this case. So in our solution here, the first thing we want to say is that the function of x states that y equals 2x squared into 2x minus 1. We can then open this bracket up. So we would have 2x squared times 2x. That will give us 4x cubed. Because when you are multiplying numbers that has the same base here, you have to add the power. So the power here is 1. So 2 plus 1 gave us this 3. Then minus 2x squared multiplied by 1 will give us 2x squared. Now what we have to do is to apply that x equals 1 after we find the first derivative. That is f prime of x, which is actually dy dx. Now let's differentiate this. From the rules of differentiation, when x has a power, we're going to have the constant first, multiplied by the power, which is 3. Then we'll have x, then 3 minus 1. Now we go to the next one here. We're going to have the constant multiplied by the power, then x, 2 minus 1. Now what we get here is going to be 12, and this will be x squared. Then minus, here we're going to have 2 times 2 to give us 4, and then x. So recall that x is -1. So we'll then have 12 into minus 1 squared minus 4 into minus 1. This would give us 12 into, now minus 1 squared is 1. Minus times minus here will give us plus, and 4 times 1 is 4. So 12 times 1 gives us 12. Then plus 4, our final answer will then be 16. And when we look at the options, we will then pick B. In this question from Jamb 2009, we're told if S equals first bracket 2 plus 3t, and then in the second bracket 5t minus 4. So we have to find the s dt, that is the first derivative of the function s with respect to t, and then find this when t equals 4 over 5. So what we're going to do here is we're going to apply differentiation to find the first derivative of function s with respect to t. And then when we find our first derivative, we then apply when t is 4 over 5. So this is what we're going to do. So we see that s is 2 plus 3t multiplied by 5t minus 4. So what we're going to do here is we're going to apply the rules known as product rule, where you have that if y equals uv, then dy dx is going to be v du dx plus u dv dx. So to apply this, we start by saying let 2 plus 3t equals u. And what this implies is that du dt is going to be, now when we differentiate this, note that when you differentiate a constant, you get 0. But when you differentiate 3t, you're going to get 3. Because this will mean 3 times t, then 1 minus 1, which is 0. And t raised to power 0 is 1, multiplied by 3 remains 3. Then 5t minus 4, we'll call that v. So dv dt is going to be, now when we differentiate this, we'll get 5. So to get the s dt, this would now be, according to this rule, so it's going to be v is 5t minus 4 multiplied by du dt. Du dt is 3, then plus u, 2 plus 3t multiplied by dv dt, which is 5. So let's expand this. What we're going to have here would be 5t multiplied by 3 to give us 15t. 3 multiplied by 4 will give us minus 12. Then 5 times 2, that's plus 10. Then plus 5 times 3, 15t. Let's tidy that up. The s dt would be 15t plus 15t, which would be 30t. Minus 12 plus 10, that is minus 2. So we apply when t equals 4 over 5. The s dt will therefore be 30 into t, which is 4 over 5 minus 2. Now from here, 5 here 1, 5 here 6. So we have 6 times 4, which will give us 24 minus 2. So our answer here is 22. So the correct option we'll pick is C, which says 22 units per second. Let's solve this Jamb question from 2009, which says, if S is, first bracket, 2 plus 3t multiplied by the second bracket, which is 5t minus 4. So find the S dt when t equals 4 over 5. Now to do this, we're going to take the first derivative of the function s with respect to t, and then we'll apply when t equals 4 over 5 to get our answer. Now we see that function s equals 2 plus 3t in one bracket multiplied by 5t minus 4 in another bracket. Now this is a case of product rule in differentiation, such that when you have that y equals u multiplied by v, we then say dy dx equals v du dx plus u dv dx. So to apply this rule, we're going to first start by taking each of them as u and v. So we say let 2 plus 3t equals u. And what this implies is that du dt can be taken. And in this case, if we differentiate a constant, we get 0. But when we differentiate 3t, you know the power here is 1. So 1 minus 1 will give you 0, and 3 raised to the power 0 is 1. And 1 times 3 will remain 3. So du dt is 3. Then 5t minus 4, we call that v. So dv dt will definitely be. Now when we open this, what do we get? V dv dt. This constant will give us 0, but when we differentiate 5t, we're going to have 5. Now let's apply the product rule. ds dt will definitely become, starting with v. So v is 5t minus 4. And then we multiply that by du dt, where we have 3. Then plus u. U is 2 plus 3t multiplied by dv dt, which is 5. Now let's open this. The s dt will then become 3 multiplied by 5t will give us 15t. 3 multiplied by minus 4, that's minus 12. 5 multiplied by 2 is 10. Then when you open that with the plus sign, you get plus 10. 5 multiplied by 3t will give us 15t. Multiplied by the plus sign, we have plus 15t. Now collecting like terms, the s dt will then be 15 plus 15t. Since they both have t, that will become 30t. And then minus 12 plus 10 will give us minus 2. So when t equals 4 over 5, the s dt will then be 30 into 4 over 5, then minus 2. 5 here 1, 5 here 6. 6 multiplied by 4, that will give us 24. Then minus 2, and then our answer is 22. Now looking at the options provided, the correct one is C, which says 22 units per second. In this question, we're told the distance traveled by a particle from a fixed point is given as a function of s, where we have s equals t cubed minus t squared minus t plus 5, all in brackets in centimeters. So we are to find the minimum distance that the particle can cover from the fixed point. Now, this is a typical question of maxima and minima values. And when you're looking for maxima and minima, you have to take the first derivative of the function and equate it to 0. This will lead you to find the point that you can then plug into the equation to then find the maximum value or the minimum value in that case. So the first thing we're going to do then is to find the first derivative. And we'll be taking the first derivative of the function of s with respect to t. So since s is t cubed minus t squared minus t plus 5, the s dt would then be, now remember we have to equate it to 0 in the end. So when we take the derivative of t cubed, 3 comes down, so we have 3 multiplied by t, then this will be 3 minus 1, minus, this will then be 2t, 2 minus 1, then minus, the power here is 1, so t, 1 minus 1, then plus 0, and all of this we equate it to 0. So this means we would have 3t squared minus 2t minus 1 equals 0. Now what we have to do is to factorize this quadratic that we have here. Now we see that 3 times minus 1 will give us minus 3. So we need two numbers that when multiplied together will give us minus 3, but when we add them together we get minus 2. So look at this, 3 multiplied by minus 1 equals minus 3, and then 3 minus 1 would give us plus 2 in this case. So it means we have to switch it, so it will be minus 3 times 1 to give us minus 3. And then minus 3 plus 1 equals minus 2. So we're going to use this. Now let's plug that into this point. We then have 3t squared minus 3t plus t minus 1 equals 0. So we group like this. From here we have 3t in common, leaving us with t minus 1. And here we have plus 1 in common, so leaving us with t minus 1 equals 0. What this means is that 3t plus 1 equals 0, or t minus 1 equals 0. And from here, we can then see that 3t equals minus 1, and then t will be minus 1 over 3. Or, from this side, t equals plus 1. So since we are seeking to find the minimum value, we're going to take the positive side. So because the question says minimum, so for minimum, we take the positive side here. So we take when t is 1. So we're then going to plug that into the equation itself. So s will then be when t is 1. So this will be 1 cubed minus 1 squared minus 1 plus 5. Now 1 cubed is 1, 1 squared is 1, minus 1 plus 5. 1 minus 1, that's 0. Then minus 1 plus 5 will give us 4. So we have 4 centimeters in this case. So the correct answer is B. This question says, what value of x will make the function x into brackets 4 minus x a maximum? So in order to find this, we have to take the first derivative of this function here and then equate that first derivative to 0 to find the value of x that will make it to be at maximum. So f of x is given as x into 4 minus x. And upon expanding this, we would have 4x, remember this is still the function of x, minus x squared. Now, first derivative of the function of x will then be, now if we differentiate 4x, we'll get 4 minus, differentiating this, we'll get 2x. And now we have to equate this to 0. So if 4 minus 2x equals 0, that is, from here we can say 4 equals 2x. And when we divide both sides by 2, x equals 2. So this is the value of x that will make it maximum. So the correct option there is C. This question says, given that s equals 3t squared plus 5t minus 10 is the displacement of a particle in meters, calculate the initial velocity. Now, this is a question that has to do with displacement, velocity, and time. Now, quickly before I solve this, let me show you something. When you have s and then working with velocity, there's also something we call acceleration A. Now, take note of this. Velocity is actually the first derivative of displacement. That is, it will be ds dt. So when you find the derivative of the displacement s with respect to time, you'll be getting velocity. And in physics, it is often given as the formula u plus at, like this. And then when you're looking for acceleration, it will be the second derivative. That is, acceleration will be d dt of ds dt. So second derivative is where you get acceleration. So I'm just putting this out there in case you find a question like this, but instead of asking you to find the initial velocity, you are then asked to find the acceleration. So you can know what to do when you find a question like that. But let's go on to solve this then. Now, we are given that s equals 3t squared plus 5t minus 10. And we're going to find the initial velocity And note that this is measured in meters anyway. That is, displacement is in meters, time is in seconds. So that's why the velocity is measured in meters per second. So velocity would then be ds dt. Now let's differentiate this. This will give us 2 multiplied by 3t plus 5. So we have 6t plus 5. Okay, so when we want to find the initial velocity, in this case, take note, we do not know the amount of time that whatever this particle, whatever the journey is going to, we do not know the amount of time is spent for the entire displacement. But to find the initial velocity, we will take the time for that to be 0. That is, at the time the record started, they started making the recordings, the time must have been 0 at that point. So when we take t at 0, so when t equals 0, we should be able to find the initial velocity at that point. And to prove that, come back to this. When we say v equals u plus at, and you want to find initial velocity u, for you to find initial velocity u, the only way we can do that is to make t 0. That way v will become u plus a into 0, so v equals u. So you see why t is made 0 in this case. So let's go on to solve. So at t equals 0, velocity will then be 6 into 0 plus 5. And what we'll have here would be 5 meter per second. So the correct option is C. This question from 2023 says, the area A of a circle is increasing at a constant rate of 1.5 centimeters square per second. Find to 3 significant figures the rate at which the radius of the circle is increasing when the area of the circle is 2 centimeters squared. Let's pick out the fact from this question. What we are given is that the rate at which the area is changing with respect to time is 1.5. So we write that as dA dt. That is 1.5 in centimeters square per second. And then we know that the area is also given here to be 2 centimeters squared. Now everyone also knows that area is calculated as pi r squared, where pi is 22/7, or you use 3.142. From here, now let's move to what the question asks us to find. We are asked to find the rate at which the radius of the circle is increasing. So that is dr dt. So to find dr dt, we have to apply dA dt multiplied by dr dA. If you look closely here, nothing is really changing. It's just dr dt, since the a will cancel the a here. But using this manner, we should be able to find an answer to this question. Now let's pick it from area. Area is given as 2. So this will be equals to pi, which is 22/7 multiplied by r squared. Now what is implied is that r squared would be 7 times 2, which is 14/22. So we can then say r is square root of course, from here, 2 here is 7 and 2 here is 11. That's what can go. So we have square root of 7/11. Now you have to punch your calculator for this, and this would give you 0.789 as the radius. We have a value for radius, but we need the RDA. To get the RDA, we'll start from A equals pi r squared. And what this will imply is that dA dr, that is taking derivative of A with respect to r, we will have, this is the constant, so the power here will multiply the constant, and then we have 2 pi, and then 2 minus 1, that's 1, so we have r raised to power 1. So dA dr is 2 pi r, so we can say over 1. Note, we are looking for the RDA, which is the reciprocal of dA dr. So when we flip this, we should flip this as well. So dr dA would then be 1 over 2 pi r, which is then 1 over 2 times pi, let's take that as 3.142, multiplied by r, which is 0.789. Now let's come back to this. The r dt would then be dA dt, which is 1.5, multiplied by the r dA, which is this 1 over. Now when we multiply this, we will get 5.022. So 1.5 times 1 will give us 1.5 divided by 5.022. So from this point, we can then find the r dt. Now, when we press 1.5 divided by 5.022 in our calculator, you would arrive at 0.29866, and then it goes on like that with other numbers. But the question itself asks us to leave our answer in 3 significant figures. So we go on to say the r dt is approximately, now first, second, third significant figure. So the next one will imply that we have to round up. So this would be 0.29. Now 1 plus 8 will give us 9. So 299 centimeter per second. So the option we'll pick here is D. This question says, find the minimum value of the function y equals x open bracket 1 plus x, then close bracket. So to find the minimum value here, we have to find the first derivative of the function y with respect to x, and then equate that to 0. So since y equals x open bracket 1 plus x, what this means is that y equals x plus x squared. Because when we open this bracket, x times 1 is x, plus x times x gives us x squared. So dy dx will then be, now differentiate x with respect to x and you get 1, plus y differentiate x squared with respect to x, you get 2x. And now we have to equate this to 0. So 1 plus 2x equals 0. Therefore, 2x equals minus 1. Now divide both sides by 2. And then x is minus half. So the minimum value is minus half, which is B. In this question, we see that we are asked to find the value of x from this function where it will attain minimum value. That is, at what value of x does the function y equals minus 3 minus 2x plus x squared attain minimum value? And to do this, yes, we have to first find the derivative of y with respect to x, and then we equate that to 0, and then find the value of x, and that will be our answer. So let's solve that. Y equals minus 3 minus 2x plus x squared. Now let's find the first derivative of y with respect to x. So dy dx. Now when we differentiate a constant, that will give us 0. So we move to the next one. This would be minus 2. And then when we differentiate this, it will be 2x. So we then go on to say minus 2 plus 2x equals 0. And what this implies is that 2x will then be, now taking minus 2 to the other side, it becomes positive. So plus 2. Divide both sides by 2 and x equals 1. So this function will be at minimum when x is 1. So the correct option here is D. Please do well to like the video and also share it amongst your friends. Please would also be wanting to receive feedbacks from you. If there's any question you would like us to solve, If there's any recommendations you would like to make, please put them in the comment section. I will definitely attend to everything. And then we'll see you in the next video. Bye for now.